For a large number of islands around Malaysia, securing electricity comes at a high price. Today, they are dependent on expensive fossil fuels that pollute our beautiful nature. But with energy can change all that. Ocean waves hold the power and the promise to produce electricity.
Our innovation, backward bend duct buoy or BBDB for short, is using the oscillating water columns to harvest energy from waves and for area marking.
Area marking is important especially for ships. For example, the Costa Concordia, a cruise ship that crashed into shallow waters because it was too dark at night and caused 32 people to die. Area marking is also important for marking diving spots. Look at these news articles that shows the fatalities caused by boats straying too far into diving spots. How can we tolerate even one death? This BBDB acts as an area marking technology that can avoid such deaths caused by these accidents by marking shallow shores and diving spots.
Our backwards bend duct buoy consists of four main parts. The first part is the impulse turbine. Secondly, the circuit, which consists of an LED, a capacitor, a rechargeable battery and a generator, all connected in parallel. Thirdly, the main body of the buoy, and finally, the sensors used to collect data. The two sensors on the right is to determine the height of the water in the air chamber, and the sensor on the left is to detect the pressure in the air chamber. The fabrication of the impulse turbine is made using a 3D printer. These following videos shows the step that is taken to produce a successful 3D model. This is the impulse turbine that has been fully assembled. The main body is made by outsourcing it to a glass shop to be made by acrylic. The dimensions were given and we commissioned the shop to make a model of a buoy out of acrylic for us. The generator is connected in parallel to a LED, a capacitor and a rechargeable battery. The impulse turbine is connected to the generator and the whole setup is attached to the buoy. This is a device used to test the prototype of our buoy. This is called a flume wave maker. Before the flume wave maker is turned on, the LED does not light up. This indicates that the capacitor is fully discharged and the battery is not charged. After the flume wave maker is turned on, the LED lights up and the capacitor will start to charge. And the rechargeable battery will also begin to charge up. When the flume wave maker is turned on, the water waves will be produced. The waves will cause the water level to fluctuate, thus causing the air pressure to also fluctuate. When the water in the air chamber rises, the air in the air chamber is compressed and the pressure in the air chamber gets higher compared to the atmospheric pressure. This makes the air goes out passing through the turbine, which makes it spin and produce induced current in the wire, thus producing electricity.
This is the data sheet that we have collected, and the highlighted row is the most efficient condition to produce energy, in which the period is 1.6 seconds and the lambda is 4.56. Moving on to the novelty and inventiveness of our innovation. Firstly, it can be used as a diving spot marker, which is powered by wave which is available in any weather at sea. And this buoy can be used to warn ships of sea conditions such as rocky sea and also shallow waters. And it can be used to power offshore military bases in case of emergency. Our product have a very big commercial potential and readiness, since the navigational aids have a reliable source of energy by converting wave energy to electricity. Plus, the innovation as well can be further scaled up to be a renewable energy generator for naval bases at Spratly Islands. Other than that, our innovation is very environmental friendly, since it is a green technology that produces electricity from waves without emitting any greenhouse gases. Other than that, sailors can avoid anchoring at coral reefs, thus protecting the coral reefs, and the fishermen can avoid fishing in protected and conserved area to protect all the ecosystem of our ocean.